Hello again, this is Mr. Russo. I'm hoping that you find these videos helpful as they are intended to assist you as you go through reviewing the material. They're almost like a chapter summary, chapter review, which of course helps you prepare for the assessment at the end of the chapter. So I have a couple pages for us to look at today that'll be very helpful in assisting you getting ready for the Chapter 7 test. So the key thing we look at is we're talking about radicals or roots, okay? We usually call them roots or radicals. And what we're talking about is that these roots can be converted to a fractional exponent. So first of all, if we have a root, we'll take a common one like the square root of 25. Now I say square root, and you say, what are you talking about? It means what number times itself twice is 25. I think we know some of that already. And if I put a little 2 in here inside the squiggly, I put it there. It's understood to be there. When you don't see it, it's a 2. And it's asking you what two numbers multiplied together times themselves gives you 25. And that's 5. Okay. What we're saying is, by the way, I'm going to keep it in blue here, the power, the exponent on 25 is also understood to be a 1, by the way. Okay. Sometimes they do things like this. They say, okay, I want you to have something like 6 to the 4th, and I want you to take the cube root, which are these exercises. So here you're saying what number times itself 3 times, okay, gives you 6 to the 4th. Now, you can multiply that number out, but it'd be very hard to do if you had no calculator in your hand. So we ask ourselves, gee, I don't want to have to multiply this 6 times 6 times 6 times 6. I should be able to manipulate and get my answer without having to expand out 6 times 6 times 6 times 6 and then figure out what number times itself 3. 3 times gives you that big gigantic number, and it won't turn out to be a nice round number anyway. So we have this rule here, okay, that allows you to convert the power over the root to the same. I'm going to convert it so that the root is where we saw it before, in the squiggly piece of the radical. The power could be there in our first example where I gave you the square root of 25 over here that I'm circling now. We realize that the root was 1. And then this turns out to be, so that's the power, P for power, B for base, okay? Well, I'd like to call it B. They call it X all the time. So the base, the bottom, or the base of the exponent. So we want to be able to convert back and forth. If I see the fraction, I want to be able to go to the right and make the radical. If I see the radical, I want to be able to go backwards and make the fraction. So let's take a look at the first questions they ask us. They ask us, can I rewrite? Now the first answer is all done out for you, so hopefully you can see what you're trying to make, right? So you're saying, can I take the square root of 2 and write it as an exponent with a fraction in it? So here's what we have. 2 is the base. We also said there's a little bit of a, blow it up a little bit, there's a 2 understood to be in there. And also, there's a power of 1 that's not shown. So the 1 is the power, the r, the root, is 2, and the base is 2. So if we follow our rule up above, we can see that we put the base on the bottom, and we get the power over the root, which is 1 over 2. Then we go to our calculator. scientific, no graphing needed. If you have your own scientific one, if you're using maybe for a science course, or you're going to take a science course, or you've already taken it, you have a calculator that tells you that you can take 2, and usually they call this the caret key. It raises it. It's almost because like there's a little bit of an invisible piece of the arrow there. Raises it to, many times you have to put that number 1/2 in parentheses, and when you do that, you get 1.41. So we're going to convert here. This should be hopefully something you've seen before. You're not looking at my video prior to doing any of the work. So here we're going to convert this so that we have the base is still the bottom. This turns out to be the power, and this turns out to be 9, the root. So that turns out to be 3 to the 9 over 7. When I use my calculator on that, so I take 3 and raise it to the 9 over 7, usually a parentheses needed, we get 4.11 on that. Okay. Here, they give us, again, the radical. The base is 12, P over R, power 8 over root. Calculator, big one, 53.3. Now here on this last problem in the chart, they give us the fraction. So they give us the power, they give us the root, and they give us the base. So now I have to convert it into a radical on the left. So I put the root inside the little curly Q squiggle piece of the radical sign. Okay. My base is on the bottom, 17, and my power, 7, goes on top. Okay. So I can go backwards with the rule as well, forwards and backwards. And here it makes sense, once again, to take 17 and raise it to the 7 over 13 power. You get 4.60. Okay. Hopefully you're okay with evaluating. On the bottom of that first page, we see an application of using a square root. Okay. And it's the distance formula, which has the square root of, and if you look at that, and you remember from the previous, way back, kind of our first and second week of using the slope formula, actually it's the first week, y2 minus y1 over x2 minus x1, the change in the y over the change in the x, called the rate of change. When we had 2 points, when we had like a 2 and a 3 and a 4 and a 5, we said, can you find the slope between those 2 points? Well, now we want to go beyond that. We want to find the distance between the 2 points. That's sometimes the length of the segment. So if you look at your graph down below, we're trying to find out how long it is from that point, that dot in red, to the other dot in red. How long is it? If it was in inches, how many inches is that total length? And then the second thing we like to find is, where is the middle of that segment? Give me another point that's smack dab in the middle. And this formula, which is really the average of the 2 points, gives us the midpoint. So let's take these one at a time. When you see an example like this on your test, the first thing you're going to do is say, well, let's see, it looks like they need a lot of x1s and y1s and x2s, so I better name that point. So looking at my grid, if I wanted to name that point, let's see, that's a -3 to the left and up 4 to the right. And if I want to name that point is 5, 2. And I want to name that point. Right? So I have 2 points now, okay? And I'm going to rewrite them over here, -3, 4, 5, 2. And therefore, the first thing I do is I say, oh, well, if this is the first point, I'm going to call this one x1, and this is y number 1. And here's another xy. That was the second point, x2, y2, just like we do with the slope. Okay? And now we're going to use the formulas to get the distance or the length. And so when I put that together, see if I got some room here. Okay. Notice that there's a subtraction sign inside the parenthesis, addition sign between them after they get squared, and at the very, very, very end, we take the square root. Let me blow that up a little so we could look at it. So if I wanted to put those values in, okay, remember, I way up at the top of the screen up here, okay, I think I'll write that real quick over here for you. x2 minus x1 squared, y2 minus y1 squared. Let's plug in those numbers. So I'm going to have 5 minus -3. We're going to clean that up. Don't do it yet. And 2 minus 4. So you want to substitute first. Now let's simplify that. Watch that double negative. Okay, that's going to turn out to be a positive 8 squared plus, this is -2 squared. Keep working under the radical sign. 8 squared is 64. -2 squared, use your calculator, put it in parentheses, that -2, or you get the wrong answer. So we get the square root of 68. If I go to my calculator, that's about 8.25. They'll probably ask you for the calculator answer on the test. Done. Pure substitution into the formula. And the midpoint, same way. The midpoint, I take x1 and x2, add those guys up and chop them in half. That's taking the average. If I had two numbers and I wanted to average them, I'd add them up and cut it in half. So you notice I'm taking the average between the x's to get the new midpoint for the x coordinate. I'm taking the average of the y's. So keep in mind, don't subtract now because we're taking the average. So if I add those two numbers up together, I've got -3 plus 5 over 2, and I have 4 plus 2 over 2. So when I'm done, I come up with, let's see that point form. That's 2 over 2. I got 6 over 2, and now I can see my final midpoint is 1,3. Okay, let's go to the next page. As we move to the second page, this really is a review of exponents rules that you had in your previous math courses, integrated with fractions, which I know many of you still don't like. So we're going to use our exponent rules. So the first couple examples that I give you are refreshers of some rules we had, okay? And then we'll throw some fractions in them. So I'll start them off with whole numbers. So first of all, if I had a power, right, I have some expression that I want to raise to a power. That's a big 4 over there. Let's make it more easy to see, okay? That exponent gets applied, gets pushed onto each piece. And when I do that, when I'm raising a power to a power, here's the rule. You raise a power to a power, you multiply the exponents. That means if I had x to the 3rd and I was raising it to the 4th, it's not 7 of them. We multiply to get 12. So first I'm going to take that 4 and I'm going to just make this a little bigger. And take that 4 and I'm put it on 2. That's 16. Now I'm going to use my rule. X to the 2nd raised to the 4th becomes, in the answer, x to the 8th. I'm multiplying 2 times 4. And when I apply that 4 to the 7 on the y, that gives me 7 times 4 is 28. And z actually has a little invisible 1 there, so 1 times 4 gives you 4. So a power to a power, you multiply. If I have division between the two of them, I divide the numbers as usual, so 12 divided by -6 is -2. But when it's time to get the exponents on the variables, I subtract when I'm dividing. So if I have 5 on top and 4 on the bottom, I have 1 left over when I subtract. 5 take away 4. There's a 1 there, even though we don't need to show it, next to the x. And I have z to the 5th over z to the 3rd. 5 minus 3 is 2. So let's do a few of these problems, and then we'll throw fractions. The first two, no fractions. So when I look at that expression, I have division, so I'm going to be using my dividing rule. So I have x over 7 over x over 2, so that's 7 minus 2, which is 2. And I have 12 minus 9, which is 3. Okay. Easy. Let's look at the next one. I'm going to put that 3 on each piece first, because you notice that I have an exponent. I don't want to divide first like I did in the last problem. The last problem, I didn't have a parenthesis raised to another power. This was a nice simple division. Well, this is a division symbol, but first I have to get those exponents out of the way using my exponent rule that says when I'm raising a power to a power, I multiply them. So when I'm done doing that, I should have in the numerator x to the 6, because 2 times 3 is 6, y times 3 times 4 is 12. And when I do it in the denominator, keep in mind there's a little 1 on the bottom next to that x, gives me x to the 4th, y to the 8th. So I got rid of, by, well, following order of operation, PEMDAS. PEMDAS says do exponents before you do any multiplication or division. So we just applied those exponents. Now I have division and I use my subtraction rule. So I get 6 minus 4 for the x, which is 2, and 12 minus 8 on the y, which is equal to 4. Okay. Now, it's nice when the numbers are nice and whole, right? Nice integers, 6, 4s, 2s. When we do this problem, it's a fraction, okay? So we still have to divide. Well, that means in the exponent world, I'm going to subtract those powers. So if you look at the question we just finished here, still on the screen, we took the 6 and 4 and took 6 minus 4. And on the y, we did 12 minus 8. So what are we going to do over here? Well, it's not going to look pretty, but we're going to have to practice it. Okay? I'm going to get x to the 11/12 take away 1/3. And y is going to be 4, whole number 4, minus fraction 5/4. So we're kind of going back to things that we need to do with fractions, which I know a lot of people always try to avoid. And we can't do these on our calculator by converting them to decimals. So if I take this 11/12 and I take away 1/3, I cannot subtract those two fractions right now because I don't have the denominators, the bottoms, the same. So I need to make this 3 become a 12. For me to do that, I take my 3 and I multiply it. See, I have to really multiply it times 4 to get it up to be a 12. But I need to do that in the numerator as well. So when I multiply that thing by 4, I get 4/12. So now that I have a common denominator, I have 11/12 take away 4/12. So when I do that, again, I'm just come down over here now. So I have x to the 11/12 minus 4/12. That's equal to 7/12. So there's my answer for x. Okay. Let's go look at how I calculate the y. For the y, I have the number 4, take away 5/4. Well, we always have to remember that any whole number can be written as a fraction. So I can call that 4/1. And now, as in the last problem, I really can't combine those yet because those denominators aren't the same. So I think it's pretty easy if I was able to change the 1 to a 4. So I have to multiply the bottom one by 4, and I'm going to multiply the top one by 4. So now I actually have 4 has been converted to 16/4. So I'm going to come back down over here, and I have y to the 16/4 take away 5/4, which is 11/4. And as ugly as it might look, that is our answer. When you type it into My Open Math, right, they're going to ask you to put the base first, raise it to parenthesis 7 divided by 12 like we did on the first page, and then you'd have y raised to the power of, and they're going to ask you to put that fraction in a parenthesis. So there is the way My Open Math wants you to write the expression right above. Okay. So let's look at the question at the bottom of the page, which is similar to the test type of question. Hopefully I left ourselves some room here. So we've got a couple rules. First of all, I've got this power that has to be brought and raised. Remember, when you raise a power to a power, you multiply. Now the bottom, I have my division symbol, but here I don't have anything else to do on the bottom. That's kind of nice. So all I have to do is rewrite the bottom. That's not being changed. And let's see what we get on the top. So we've got to multiply those two fractions together. When we multiply two fractions together, we can crisscross reduce, or we could just go straight across. When we multiply straight across, numerators with numerators, denominators with denominators, I get 4/10. 4/10. All right, let's put it up there. We're going to want to change that later. Okay. And on the y's, I've got to multiply 4/3 times 4/5. So tops with tops, numerators with numerators, 16, 15. So I get 16/15. So I have my ugly looking fractions. Okay. And now I'm going to divide. Remember, when we divide, if I gave you x to the 4th over x to the 1st, we subtract and get 3. So now, first of all though, I have to subtract the x portions, and I'm going to subtract the y portions. So I'm going to get x to the 4/10 minus 1/5. We'll have to mess with that. And y to the 16/15 take away 7/15. So let's take, let's take each one of those fractions that we have, and let's do our calculations with those. Let me get some erasing done here. Hold on. So let's do these subtractions that we have. 4/10 minus 1/5. Well, like that previous problem, I can't subtract those until I convert the fifths to tenths. And when I do that, I get 2/10. So I'm going to have 4/10 minus 2/10. So 4/10 minus 2. Numerator, 4 minus 2 is 2 over 10. Okay, that reduces. If I slice that in half, this gives me 1/5. So I've got a final answer. Let me go back to that problem down here. And we've got the x turns out to be 1/5. And the y, oh, that one's easy. I get 16/15, take away 7/15. I got a common denominator. Yay, I don't have to change anything. I got so many 15ths. And that turns out to be 9/15. But like we were able to take 2/10 above to 1/5, I have to slice everything through by a 3, and I get 3/5. So that 3/5 is my exponent. So my final answer is x to the 1/5, y to the 3/5. So you have a little fraction review there. That's the rules are kind of easy, but sometimes we have our fractions we got to reduce, we got to get common denominators, and we'll see that in our next chapter 8, which is all about fractional things. Okay, I think I'm going to stop the video here, and to do those last problems on solving the equations, we'll set up a second video. So this will be the first video, and then we'll follow up with a second one.